All right, in this little presentation, we're going to take a look at the main components of a computer. Now, I have listed here CMP 152, and the reason I do is because in that class, that's where we actually put a computer together and we take a computer apart. We also work with a Raspberry Pi, which is a mini one-board computer, just an amazing little thing. Usually students will make a retro gamer out of it, something like that. So we do a bunch of labs. We deal with storage in that class. Pretty much every week we're doing labs in there. And so 152 builds on what you're learning here, which is just some basic things. I'm going to add some other stuff to it. This video will basically cover the basic portions of a computer, what they do, and then we'll take a look at, well, how do you go about actually getting the parts to build your own computer. So I'm going to add that in there, and then I'll do another video where I use a simulation to actually put a computer together. And again, a simulation is not bad because you need to know the logical process of actually physically doing the thing. And then in 152, you can actually take that class and physically do that. So let's take a look. Here's the parts. The CPU, which gets probably more credit than it should, that's a central processing unit, but it's called the central processing unit for a reason, because there is a multitude of processing units actually on the computer. When you look at a computer board, you see a bunch of different chips on there. We'll pull one up in just a second, and you'll see just tons and tons of things going on, and that's why the CPU is referred to as the central processing unit, because it's central to the system, but it's also a general processor. It's not designed to do one single thing. In comparison, you actually have what we would call controller chips that control the flowing in and out of your network, or the flowing into and out of your storage device. And those are processing units. They process a specific type of data, where a central processing unit is meant for us to do whatever we want to, like move this mouse around on the screen. The motherboard, or the main board, is what the CPU is connected into. And so it's that main system board. And it's important to understand those terms. The CPU is actually a chip that goes into a socket on the main board. The memory also is on that main board, and that is often referred to as RAM, or random access memory, which is also volatile memory. Volatile, whoops, spell it wrong all the time. So volatile memory, meaning that if you turn your computer off, anything that was in RAM goes away. So when you go out to buy a system, they used to just say RAM, but they tried to make it more user-friendly and they call it memory. I don't know if it's more user-friendly, but that's what they do. In this day and age, Windows takes at least 3.5 gigabytes of memory, or RAM. So if you've got a Windows system and it's running on a 4 gig set of memory, then you'll realize that that's actually pretty full, and it's harder for the system to deal with it when it's at full. So standard today, these days, you'll usually see when something's being sold 8 gigabytes of RAM. And that's a little over double of what you need out of Windows 10. And it's probably going to maintain that for a while. It's always been that case, oh, you need more RAM, you need more RAM. Well, we've finally gotten to the point where we don't really need more RAM. So in my system here at home, I have 16 gigs, but the truth is I don't ever use that. And it's important to understand that this thing here, memory, doesn't necessarily speed up your system. So a lot of people will say, oh, my system's so slow. Do you think I need more memory? Well, if the memory is being totally used, then the answer is yes. So if you got 4 gigs and Windows is using 3.5 of it, as soon as you load 2 other programs, you're out of RAM. And what it's going to do is it's going to start using storage as a location for that. Well, storage is 40 times slower at least. And so when that happens, your system slows down. That's the only time memory is going to help you. So the more is not always the better. And I do know students will be like, I just got a system and I think I'm going to max it out 24 gigs of RAM. Why? You're not going to use it. That's like basically saying, well, you know what? I'm going to build a house that's 72,000 square feet, and that ought to do me enough. And it's like, okay, what are you going to do with it? You're going to have a store in there. What are you using the RAM for? And so it doesn't make a system faster the more you have. But people that are using, say, they're doing video rendering, they're doing AutoCAD, those files alone to work on them are massive. And so we'll look at, how this goes back and forth. So let's look at storage. All right, so storage, actually I'll leave my 8 gigabytes here. Storage is where we put everything. So that's either a hard disk that has a spinning platter in it, or these days a solid state disk, which is much faster. It's about 40 times faster than a hard disk. And it's really good stuff. That's what we like these days is SSD. If not, try to do a combo where basically your OS is stored on your SSD and then the rest of everything else is stored on a cheaper hard drive. The faster something is, the more expensive it's going to be. So this is non-volatile RAM. So this is non-volatile. And it's going to be much bigger. These days the standard is 1 terabyte, which is 1,000 gigabytes, roughly. And I do say roughly. Okay, so that's a lot bigger. That's because that's where we store stuff. So again, if you're in my 103 class, then you just think about the fact that, well, in your house, in your garage, it doesn't matter where you are, you have more storage space and less shelf space. So again, a kitchen's a perfect example where you have this countertop, and that's where you cook your food or prepare your food. You do all that stuff there, and it's limited. You can't take everything out of your cupboards and just set it on the countertop and expect things to be okay. You just won't have enough room to do anything. And so you have these cupboards. As a matter of fact, you even have a special one that's called a refrigerator. And you put food in there and you store your food in there. But then when you need the food, you take it out. The only difference between a CPU and what we do in reality is that the CPU actually just copies the file. That would be as if you could not actually take the beef out of your fridge, but you could copy the beef out of your fridge so that the beef is always there. It never needs to be replaced. So that's the only difference. So you need a ton of storage for all those family videos and those illegal downloads, all that other stuff. You need tons of storage for that, and less place to put it when you use it, right? So big difference. If you actually could afford a terabyte of memory, it would cost you $100,000 probably in a system. Memory is more expensive. You can go out and price a really high-end system that's got, I did 128 gigabytes, I think, on a server, and that's expensive to do. It's just more expensive. On a server, you would use it though. All right, now the system buses are the connectors. So the system buses connects the storage and the memory, and they're on the main board with the CPU. That way, what's happening is that you move a mouse over and the CPU is computing where that is. That information's traveling along a system bus to the output, to the graphics card, so that you can see what's going on. When you double click something, that is traveling through a system bus to the memory, then to compute it in the CPU, to put it back in the memory, to go and show the result on the output. That's this complicated process. So system buses are, it's not what we think. We think of like a bus that travels down a road. The system bus is actually more of the road than it is the bus. And that comes from electronics and electricity and the fact that they call those buses. But anyway, that's what a system bus does. It connects all this stuff together. Input, you know what that is, your keyboard, touch, even voice is input. So your speaker, your microphone can be input, your speaker can be output. And then output is things like your graphics card. I put that one down specifically because they have processors particularly for the graphics. And of course our systems are very graphics intensive. And so a lot of the processing actually won't happen in the CPU. It'll actually happen at the graphics card if it's graphics capable of doing that. And so running a browser, that's not a big high graphics demand. Running a 3D game, that's a high graphics demand. And that's a special output. And these graphics cards, of course, can cost quite a bit. And so those are the main components. And when you put a computer together, everything's going to be plugged into this main board. And I tell people all the time, it's a lot easier than working on a car or something like that. A car's got thousands of parts in it. And a computer does too, but we can't replace those parts. That stopped someplace in the 70s. Instead, you have this one thing. It would be like saying that you could go get a car, but you didn't have to put everything in. You just put the motor in, and then that would connect to the system bus that's already there. That'd be the CPU connecting to the main board. But that's not what you do with a car. It's very complicated. But in a computer, it's not. You got like 5 pieces. You put them together, and as long as you don't shock it, it should work. And that's what I'm going to show you in building a computer. Right now, we're going to take a look at, well, what about these parts, and how do you go about this? What do you need to know? Because there is some technicalities that you have to worry about when you're dealing with computers. So let's jump over. This is ASUS's site. I thought I would start here. I usually get ASUS motherboards, or I get Gigabyte motherboards, and that's because they're made by ASUS. There's other good motherboard makers, but I usually stick with those boards. And so when you're trying to build a PC, you have to think about, what is it that I want? So for instance, maybe you want a specific graphics card. If that's the case, then you look up that graphics card and you see what the specifications are, and then you make sure you get a motherboard that's got those specifications. Usually people are looking for certain features, or they're looking for a certain processor. That's why these right here are broken down into Intel and AMD right here. The Asus Prime boards are really, really nice. That's why they call them Prime. And then you've got Republic of Gamers, or their ROG boards, and those are more heavy duty. And I know you think, oh, gaming is heavy duty. It's no more heavy duty than anything else you do. But putting it in, they realize that gamers are putting these together, who are people that may damage them in putting them together. They may not know everything they need to know. And so they include a lot of other things that help you not to damage your system. That's a lot of what the gaming stuff does for you. But let's just look at one of these just for instance. Why not look at the biggest one, right? Why not look at the best? Now this system, I'm going to compare another picture. Let's look at the gallery so I can show you what the board looks like itself. Let's look top down on that. All right, so this is where your processor is going to go. And you can't actually see it. I'm going to have to pull up a board that doesn't have the fancy stuff on it. But this is covering up the ports on the board, and this is covering up a lot of the chips. And the reason why is, one, don't damage it, don't drop something on it. That's what I told you about their gaming systems, right? And also to pull the heat away from it. So a lot of this will be attached to a processor, so it'll pull the heat away, besides just looking, awesomely cool, right? That's just like, wow, I want that one. Those cost hundreds of dollars. And so I'm gonna just go to their tough boards. Actually, yeah, that'll be a little, we'll look at this one, and then we'll look at one of their Prime boards. So let's look at the gallery on this one. Hopefully. It doesn't want to go to the gallery. It's taking forever. All right, let's try the Prime one, then it doesn't really matter. There's a nice old green board for you. Let's just look at that one. Oh, that one doesn't really have too much to show us. So, whoops. Click on the right thing. That doesn't have too much to show us either. But we do see there's the processor. Right down under here is going to be some system bus chips that control the system bus. And this is going to be a nice heat sink to keep that off of there. You'll notice that that's probably also under here as well. Got some graded holes right there. And so that's what a main board looks like. If we can get this picture to come up, that would be awesome. Oops. Apparently they don't offer that one anymore. Sorry, I'm wasting your time here. Let's look at this one. There we are. So we'll zoom in on that. Right, so there's where the processor sits on this. Here's your RAM that's coming in a little sideways, interestingly enough. And then here is probably the front side bus chip that handles those buses. And it's got a little heat sink on it. And then you see a bunch of other stuff all over the place. And so a lot of that is going to be just different kinds of processors to handle what it needs. Now back to the point of, okay, well, how do I go about buying it? Well, again, most people are coming from a certain way of looking at it. And so what I tell people is usually people are looking for a certain processor. And so if we go to their motherboards, we can say, okay, we're looking at AMD. AMD's taken a lot of the market right now. They're really pushing things with their integrated graphics in it. So let's say that we look at this TUF Gaming one. So it's giving us a bunch of stuff that can be really confusing, but it tells us right here that it's got an AMD AM4 socket and that it's ready for the second, third generation AMD Ryzens. All right, so basically this socket is what we want to make sure our processor has. So we want to make sure that when we're getting a processor that it's an AM4 socket. Otherwise it actually won't fit that. If we look at the gallery again, ooh, it's got RGB lighting, Aurora Sync. That's cool. It'll do colors. So we can look at the chipset, and then here again is the processor, and then here's the memory, right? So it'll take 4 DIMMs, so it'll have 4 slots. It'll take up to 128 gigs, and it's DDR4, and then it's got a bunch of these numbers after it, right? Now, in the 152 class, we learned this. I mean, the 151 class, we learned this stuff of what that RAM is. What does this mean? What is a 3400? You know, what's a 4400? That kind of thing. But the main thing is that when you're going out and buying something, you have to realize that those numbers need to be compatible, right? That when you go out and buy a processor, then it's going to have to be that AM4, otherwise you're not going to work too well. When you go out and buy RAM, it's got to be one of these that's gonna fit. So they're telling you if you put a 3rd gen AMD Ryzen in, then this is what it's got to be. If you put a 2nd gen in, then this is what it's got to be. And for the most part, those are the same, other than it goes up a little bit, right? We can put a 4400 instead of the 3600. Now, something that really helps out is a PC parts picker. You can actually use this to figure out what you need to buy. You don't actually have to buy it from them, but you can go through and say, hey, this is what I need. And they make things easier because they should be picking everything that fits together and putting it together for you. And so let's look at a system builder and see how this leads us through. So let's choose a CPU. And let's just shoot the moon. I would definitely never buy this processor or this one or this one because performance-wise, you're just not going to get what you think you're going to get out of that. If we look at user benchmark, you can't see the difference between 10%. So it's very, very hard to see that. User benchmark is a great place to go because it's actually where actual users send their benchmarks to. So you can compare on user benchmark different things that you want to compare. Right, so this right here is just showing, according to user ratings, there's a 9400F. And the price is only $150. As a matter of fact, I helped somebody put one of those in their system back when this wasn't really even tested. And it basically doesn't have a graphics processor, so you have to have your own. So, and what that means is, this is kind of important, is that if I put that 9400F in a system that has an HDMI port on the back, that HDMI port's not going to do anything, because that HDMI port is dependent on what the processor, the CPU, has in it, and it doesn't have any graphics. Because there's no graphics, the HDMI port doesn't do anything. But I put one in that does have graphics in it, like this one, and then that HDMI port will work. And so on that particular system, I knew the person was going to be playing games on it, and they were going to buy their own graphics card. So graphics in the CPU is not going to really do much good when you bought a graphics card to do that for you, right? So saved a little money there. But you can actually pull up different CPUs and rate them side by side on this. And that's the point I was getting to, user benchmark. You can test anything. See, they got GPUs, solid state drives. It's a great site, because then you can pull it up and you can go, whoa, wait a minute, this is $150. How poorly does that test to the Ryzen, right? This is $175, and let's see. So there's your 8 core points. So it's a little higher. It's actually a little higher on the 1 core. So your average benchmark is what is that, 0.6, 0.7 away? That's probably worth the $25 in my opinion. But again, depending on what you look at, right? What are you looking at in order to, like, there's your i3 9100. And so you can pull them up side by side and see which one is better, so that when you're over here picking something, you'll know whether or not it's worth the money to do it. How much better is the Ryzen 9 over this 7? Probably not $100. That's more bragging rights. So let's just say I'm going to choose that one. And so then I'll choose a cooler, which really the Ryzen 7 should come with a cooler, to tell you the truth. So I'm going to just go back. This should come with a cooler. I want to make sure though later. So now I choose a motherboard, and here's 235 compatible boards. So PC Part Picker will help you make sure that that's actually going to work right. So there's the Asus ROG right there. Bunch of stuff. So anyway, this video is getting a little long, but I wanted to show you those sites and kind of explain a little bit of that. That basically, if you're just going at it from your own memory kind of standpoint, that you have to pick something first. So if you really like Asus and there's a certain board with features on it, you pick the board, and then you find out, okay, well, what CPU can this take? And it'll say right there what kind of socket that is, and you need to find a socket that will actually, a CPU that'll fit in that socket. Same with memory. Or you say, I want this kind of CPU. And then you go find a motherboard that fits that. And that usually is, again, that's usually pretty scary, whoops, to some people, because there's lots of numbers on here. But if you spend some time doing it, it's not really as hard as people think, right? I can go out and find a 3rd gen AMD or a 2nd gen AMD Ryzen, and that'll work. That's what this is telling me. And then I can make sure I buy some RAM that will work in that, right? I'm just using their website as a guide. The other one that I wanted to show you is Newegg. So PC Parts Picker will be really good for finding things, making sure they're compatible, but the prices may not be the best, even though it's pulling from a lot of places. And so you can actually come in to Newegg, and they have a lot of deals on different things. And they even have things that what they call bare bones systems, where basically a bare bones system is you get the case, and you get the processor, you get the motherboard, and you get the RAM, all part of a kit. And then you can put it in, and then you buy the other stuff, because the other stuff should be compatible. Anyway, if you have questions on this stuff, let me know. I usually will just make another video to answer your questions. But this is part, again, what we do in 151 and how we get through that class. Lots of stuff. So I put 152. I don't know why I put 152, but that's 151. And that's only offered in the fall. Anyway, if you got questions, let me know. We'll talk with you later.